everyone, this is your Kalpana here. In this video we're going to see a problem from partial differential equations. So let's get going. Problem: form partial differential equation from z equal to x square f of y plus y square g of x by eliminating the arbitrary functions f and g. So we are given a relation, we are asked to form a partial differential equation by eliminating the arbitrary functions f and g. Okay, so let's begin. Given relation, z equal to x square f of y plus y square g of x. Consider as equation number 1. Now let's partially differentiate it with respect to x. So here we are going to find the equations with respect to, which involves p, q, r, t, and finally if necessary s. Okay, fine. Now we are going to find the equation involving p. For that we'll partially differentiate one with respect to x. Partially differentiating 1 with respect to x. Just apply dou by dou x on both sides of 1. Or you can do directly, you can just skip this step. It is not necessary to take dou by dou x on both sides. Okay, you can just do directly. But in order to avoid mistakes, I am taking dou by dou x. Okay, fine. This gives us dou z by dou x equal to, here we are partially differentiating with respect to x, so we'll treat y as constant. Here f of y is treated as constant and y square is treated as constant, right? And this gives us f of y constant into dou by dou x of x square plus constant y square into, okay, it's not necessary to write this step also. You can just write directly. Since we have a notation dou z by dou x equal to p, let's replace it by p. We'll get p equal to partial derivative of x square with respect to x is 2x into f of y. You can just directly write this, okay? By partially differentiating 1, you'll get this, okay? Y square into partial derivative of g of x is g dash of x. Now consider it as equation number 2. Fine. Now see this equation involves p, okay? Fine. Now let's find the equation involving q just by partially differentiating 1 with respect to y. Partially differentiating 1 with respect to y. Just apply dou by dou y on both sides of 1 or do directly. This gives us dou z by dou y equal to, here we are partially differentiating with respect to y, so we'll treat x as constant. Here x square and g of x are treated as constants. Okay, you'll get constant into partial derivative of f of y is f dash of y plus constant into partial derivative of y square with respect to y is 2y, right? And also we know that dou z by dou y can be replaced by the notation q, since dou z by dou y equal to q. So this gives us q equal to x square f dash of y plus 2y into g of x. Consider as equation number 3. Now we got the equation involving p and the equation involving q. Now let's find r and t, if necessary s. We know that r is nothing but dou square z by dou x square, right? You can write this as dou by dou x of dou z by dou x, right? Partial derivative of dou z by dou x, which is p, gives r, right? Since this is nothing but p, so partially differentiating equation involving p with respect to x gives equation involving r. So this is the equation involving p. Here p is nothing but dou z by dou x. Okay, fine. Now let's find equation involving R. So this is our equation 2. Here P is nothing but dou z by dou x, and this is our equation 3. Here Q is nothing but dou z by dou y. Or you can just write like this if you are confused a bit. You just can write like this. Okay. Dou z by dou x is nothing but P. Dou z by dou y is nothing but Q. And this is the equation we got now. Okay. Fine. Now let's partially differentiate two with respect to x, so that we'll get equation involving R. See, dou P by dou x gives R, right? So we are partially differentiating this equation with respect to x. Just apply dou by dou x on both sides of this equation. You can just directly write this as R here, okay, equal to 2 into, here we are partially differentiating with respect to x, so we'll treat f of y as constant. You can write this as 2 into constant into partial derivative of x with respect to x is 1, or you can write this, okay, partial derivative of x with respect to x plus constant y square into partial derivative of g dash of x is g double dash of x. This gives us r equal to 2 into partial derivative of x with respect to x is 1 into f of y plus y square into g double dash of x, or you simplify, you'll get this, right? Consider as equation number 4. Now we got equation involving R, just R equal to 2 into f of y plus y square into g double dash of x, which is equation number 4. Let's now find equation involving t. We know that t is nothing but dou square z by dou y square. We can write this as dou by dou y of dou z by dou y, right? And also we know that dou z by dou y is nothing but q. So partial derivative of q with respect to y is our t. Now in order to find the equation involving t, we'll partially differentiate equation involving q with respect to y, so that we'll get the equation involving t. Okay. Now let's partially differentiate equation 3 with respect to y. Partially differentiating 3 with respect to y. Just apply dou by dou y on both sides of the equation. You can choose q or dou z by dou y for LHS part. Okay, and this is your RHS part, right? You can either choose q or dou z by dou y. Let me try and show you using this. I'll get dou by dou y of dou z by dou y equal to dou by dou y of RHS part, x square f dash of y plus 2y into g dash of x. Here dou by dou y and q both are same, okay? Q is nothing but dou z by dou y, or dou z by dou y is nothing but q, simply. And this gives us dou square z by dou y square equal to, here we are partially differentiating with respect to y, so we'll treat x square and as constant and g dash of x as constant. You'll get constant into partial derivative of f dash of y with respect to y is f double dash of y plus 2 into constant g dash of x into partial derivative of y with respect to y is 1. Since dou square z by dou y square equal to t, just replace it by t, you'll get t equal to x square f double dash of y plus 2 into g dash of x. This is your equation number 5. Okay. Here what we have done is, here 2 and g dash of x are constants and we have a variable y. We'll partially differentiate this y with respect to y so that you will get 1. Or you can just write this as 2 into dou by dou y of y, simply. 2 into dou z, partial derivative of y with respect to y is 1. So that here you will get 2 into 1 into g of x, which gives us t equal to x square f double dash of y. 2 into 1, 2 into g dash is 2g dash of x, right? Which is our equation number 5. Now we got equation number 5 involving t. See, in our Q we have g, it's not g dash, it's just g, right? So you don't have or you don't get any g dash here, it's simply a g. Okay, fine. Now we got t equal to x square f double dash plus 2g. F double dash plus 2 into g of x, which is 5. Okay, write equation carefully. It's g, not g dash. Okay, I corrected just now. Fine, now let's find, now observe all these equations. Here in P you have f g dash, here you are having f dash g, f dash g dash, g double dash, f double dash and g. So by looking at these equations, we can say that we don't have any f dash g dash, I mean an equation involving f dash g dash or f double dash g double dash, right? We have variations. Here you have f dash, sorry, here you have f and g dash, f dash g, f g double dash, f double dash g. So what we'll do is, we didn't find any similarity, f dash, we don't have any equation involving f dash g dash, both f dash g dash, both f double dash g double dash. So what we'll do is, we'll find s also. Okay, because it's not possible to find a partial differential equation using these 5 equations. Okay, so for that purpose we'll find s also. So in this problem there is no possibility for substitution using these 5 equations. So now we are going to find s. S is nothing but dou square z by dou x dou y. You can write this into 2 ways. Dou by dou x of dou z by dou y, or dou by dou y of dou z by dou x. Both gives the same thing. Okay, here dou z by dou y is nothing but q, and this one dou z by dou x is nothing but p. This gives dou q by dou x and this gives dou p by dou y. So you can find the equation involving s by partially differentiating equation involving q with respect to x, or you can find the equation involving s by partially differentiating equation involving p with respect to y. So you can go for this or this. Okay, I'll go for this. Now I'll pick equation 3 and I'll partially differentiate with respect to x on both sides. Okay, partially differentiating 3 with respect to x. Just apply dou by dou x on both sides of 3. This gives us dou q by dou x equal to, here we are partially differentiating with respect to x, so we'll treat y as constant. F dash of y and y are constants. 2 is also a constant. Now partial derivative of x square with respect to x is 2x into constant f dash of y plus constant into partial derivative of g of x with respect to x is g dash of x, right? Since dou q by dou x gives s, this is nothing but s, right? So s equal to 2x into f dash of y plus 2y into g dash of x. Consider as equation number 6. See, it involves f dash and g dash. Both are similar, prime, prime. Right? Similar is nothing but, I'm not telling that f dash is similar. I'm telling the pattern. Here you have pattern f dash. Here also you have pattern g dash, right? So now you got something same. Fine. Now, with the help of all these equations, we'll find the required partial differential equation. So here I'll consider S as a game changer to our problem. Now I'll take this S. S equal to, S is nothing but equation involving S, okay? 2y into g dash of x. Now we can find partial differential equation using this. But here we need the value of f dash of y and g dash of x. Now let's find it from P. From 2, we have 2x f of y plus y square g dash of x equal to P, right? So from this you can find the value of g dash of x. So let this term as it is and take this term to RHS, you'll get P minus 2x into f of y. Now take this y square to RHS, you'll get g dash of x equal to 1 by y square of P minus 2x f of y, or you can just write it as P by y square, or P minus 2x into f of y by y square, better. Okay, so now we got the value for g dash of x, right? You can replace this g dash of x using this value. Fine, very good. Now what we'll do, we'll find the value of f dash of y using equation 3. From 3, it is easy, right? It's easy. You pick S, which has same pattern, and now we need the values of f dash and g dash. Find those values using any of these equations, put it in, and then simplify it. You'll get the final partial differential equation. If you didn't get, you have to do some manipulations. Fine. Now from 3 we have x square f dash of y plus 2y g of x equal to q, right? Now we are looking for the value of f dash of y. So let's write this term. Take this to RHS. Take this x square to RHS. You'll get f dash of y equal to q minus 2y g of x by x square, right? Fine. Now substitute the values of f dash of y and g dash of x. This gives us s equal to 2x into f dash of y is q minus 2y into g of x by x square plus 2y into g dash of y is p minus 2x into f of y by y square, right? You can cancel 1x and 1y, so that you'll get s equal to 2q minus 4y g of x by x square plus 2p minus 2 to the 4x f of y by y. If we have cancelled 1x, right? So you'll get only x here. Now take the LCM of these two. You'll get s equal to xy. See, in the denominator first term we have only one x, only x. You don't have y, right? So what we'll do is we'll just multiply this y to this numerator of first term. Okay. y times 2q minus 4y into g of x plus, here you're having y in the denominator, so close y and multiply this x to this numerator, you'll get x times 2p minus 4x f of y, right? Now make a cross multiplication this xy, or just multiply both sides of the equation with xy, so that you'll get sxy equal to 2yq minus 4y square g of x plus 2xp minus 4x square f of y. Okay, take 2 common from these two terms, you'll get, or let it be, just leave it, don't take 2 common. Alright, 2px plus 2qy. Now take 4 common from these two terms, only 4, not x square, okay? Only 4 common from these two terms, or minus 4 common. We'll get minus 4 times x square f of y plus y square g of y. We have seen this somewhere, right? Now check in the equations, which is similar to this here. From 1 you have z equal to x square f of y plus y square g of x, since x square f of y plus y square g of x equal to z by 1. Just replace it by z, you'll get sxy equal to 2px plus 2qy minus 4z, right? We always write the parts that involving p, q, r, s, t, whatever in one side, and the terms that does not involve p, q, r or s or t in one side, right? So here we having minus 4z, right? Let's write this to LHS and bring this to RHS, so that you can write the terms that does not involve any of the p, q, r, s, t in one side, and the terms that involves p, q, r, s, t in the other side, right? So this gives us 4z equal to 2px plus 2qy minus sxy, which is a required partial differential equation. Therefore, 4z equal to 2px plus 2qy minus sxy is the required partial differential equation. This completes the problem. Now, we have seen the easy way, right? Without using the brain too much. We just solve this problem. Now, let's see the other type. Okay? For that, we need to use our brain. While finding partial differential equation, most of the cases, what we'll do is, we'll pick P, Q. Okay, these are the important things we have to keep in mind, that sometimes we may need to multiply P with X, Q with Y, and S with X, Y. Okay, just remember all these. Okay, now let it be Px, Qy, and Sxy. Now observe equation P. Here you're having 2x f of y plus y square g dash of x, and here q equal to x square f dash plus 2y g of x. Okay, what happens if we multiply x to this? You'll have 2x square f of y plus xy square g dash, and if you multiply this with y, you'll have x square, that is qy equal to x square y f dash plus 2y square, right? Here we'll get 2x square and here you'll get 2y square, right? 2x square, from 2x square f of y plus 2y square g of x. Okay, if you add px plus qy, you'll get 2x square f of y plus 2y square g of x. By taking 2 common, you'll get x square f of y plus y square g of x. which can be replaced by z. Okay, got it? So put on paper. You can't just imagine all the time. You need to use pen and paper. Right, now we'll multiply p or equation 2 with x and q with y and see what happens. Okay, 2x square f of y plus x square y square x g dash of x plus x square y f dash of y plus 2y square g of x. Right, here you can take 2 common from these two terms. You'll get 2 times x square f of y plus y square g of x. Right, now observe these two terms. Okay, you can find xy in both the terms, right? So let's take xy common, right? If you take xy common, you'll get xy times yg dash plus x f dash. We have seen this similarity somewhere, right? Yes, S has that similarity, right? So we can just replace this by z by 1 plus xy into, if you take 2 common from this, you'll get s equal to 2 times x f dash of y plus y g dash of x, so that this gives us x f dash of y plus y g dash of x equal to, if you take this to LHS, you'll get s by 2. Now you can replace this term by s by 2. You'll get, right, is equal to 2z plus sxy by 2. Now take the LCM, you'll get 4z plus sxy by 2. In LHS you have this, right? Now bring this to LHS or multiply both sides of the equation with 2. You'll get 2 times px plus qy equal to 4z plus sxy, or 2px plus 2qy equal to 4z plus sxy. As I said you earlier, let's write all the terms that involves p, q, r, s, t in one side and the terms that does not involve any of these 5 on one side. So it's easy to bring this to LHS, right? Let's bring it out. You'll get minus sxy equal to 4z, which is the required partial differential equation, right? Always remember these 3, okay? P can be multiplied by x if it's necessary, but in most of the problems we'll be using px, qy, sxy. Okay, if you observe, if you get p, you can just try by checking px. If you get q, equation involving q, then you can just multiply it by y. If you see s, equation involving s, then multiply it by xy. If it's necessary, then you can try this. Here we tried px plus qy. From that we got the required partial differential equation. And this is the same equation we got without using our brain, right? We didn't use brain that much. Fine, now this is all for now. Fine, I hope you'll understand. Well, we have seen a problem in this video from partial differential equations. I hope you'll understand. We'll see you in the next video. Until then, bye. Thanks for watching.